Hello everyone, today we're going to be learning about Pearson's correlation coefficient. So far we've learnt about correlation, we've learnt that when we're thinking about correlation, we're thinking about a relationship between two things because we're in this topic of bivariate data analysis. So we're looking at comparing two things, two variables in our data set. So our goal for today is to be able to calculate what a correlation coefficient is. It could be for body measurements, but it could be for other things as well. Using technology, so our calculators in this case, you're not ever going to be asked to do it by hand, which is great. And to be able to interpret what the correlation coefficient means and the strength of it as well, and interpret the sign. Okay, so in terms of correlation, what we're talking about is some sort of relationship, association, or strength. Okay, where we were talking about causality before. So, for example, if one thing's going up, the other thing's going up, or if one thing's going up, the other thing's going down. So, just remember the different types of relationships or associations. So, the correlation coefficient is given by a value called R, which stands for regression or correlation in this case. And we can have different forms. So just to recap from last time, if you've got like a scatter plot and your points are just going everywhere, then we say there's no linear association and there's no correlation, no relationship. So in that case, the R value is 0. If you have a perfect line leaning to the right, we say it's positive because it's positive gradient. And we say the correlation is +1. Similarly, if it's negative, it's leaning to the left, almost a straight line, -1. So it's really important that you understand that Pearson's correlation coefficient R has a value between 1 and -1. Okay, so that's kind of really important that we are getting that. So you want to highlight that. The closer it is to -1 or 1, the stronger the association. And here are some approximate values and varying strengths. So we did some sort of work on this last time. So if something's weak, its correlation may be 0.3, and it's leaning to the right, so it's positive. 0.5, you can see that the dots are aligned a little closer. 0.9 is almost at 1, so they're even closer again. Okay. In these pictures here, again, that's just reiterating what we did before. So just to clarify, a correlation coefficient is a number between 1 and -1 that measures the correlation between two variables or the relationship, okay? And I showed you it in pictures before, but it can be on a scale as well between 1 and -1, and you can see kind of all the different things between that. So let's have a look at some examples. In this first question, it says each pair of variables has a strong correlation, so it's telling us that there is a strong correlation. They want us to determine whether each pair have a causal relationship, and for those that don't, suggest an external factor that may affect the correlation. So what's that asking? It's saying, is something in these two variables causing something else? Okay, so for example, the height and the weight of an animal. Is that causal? So you might say to yourself, okay, is the higher an animal generally mean that it's also more heavy? And I would probably say most of the time, but not always. So for example, if you have a meerkat, it doesn't weigh very much. If you have a giraffe, it weighs a lot. If you have an elephant, it weighs a lot. So I would probably say, yes, this is a causal relationship. And you might just list that example, okay? E.g. a meerkat, which is my favorite animal. That's so cute. Meerkat versus, let's say, giraffe. Number of drinks sold at a concert. Well, let's have a think about this one. So basically, at a concert, the more people there are, the more drinks will be sold. That's true, so I'm going to say that that's causal. The amount of traffic and the time the bus takes to get to school, definitely causal. Then what we're going to do is we're going to have a go at deciding whether these correlations are positive or negative. So I'm going to let you do that one. But basically, if it's leaning to the right, it's positive. If it's leaning to the left, it's negative. In number 3, they want you to match. Okay, so similar thing. You can just write the letter name down here. So if it's strong positive, so for example, for down here, you'd probably want to write G for that one, etc. Okay, so I'll let you finish that off as well. That's not too hard. That's just reiterating what we did last time. And then these ones here, number 4, it says, what type of correlation would be represented by scatter plots that had the following correlation coefficients? So it's asking you now to go backwards. So in this question up here, they gave us pictures and we needed to match them with the descriptive words. This time, they're giving us just a value. So we know if it's 1, we would say that is strong positive. 0.8, probably say that is still strong positive. Negative 0.7, probably moderate to strong negative. You get the idea. Okay, so I'm going to let you fill those ones in yourself as well. That's not too hard. This bit here is a bit more tricky, but in this example, there's a table and it shows the height and age of a student. Okay, and it's showing obviously as they grow, their height increases. Okay, the first bit they want you to do is to calculate the value of the correlation coefficient and answer to 4 decimal places, and then to describe the strength of what that is. So what I'm going to do is I'm going to help you by just showing you what to press on the calculator. So if you've got your calculator there, you need to get it out and do this with me. So the first step is to click mode 3, or it may be mode 2 for you, depending on your calculator. So mode 3, then 2, and you want to get these 2 columns in front of you. Okay. You then also want to turn the frequency on. So you're going to go Shift, Setup, scroll down to where it says Stat, press 4, and hit 1 for turn the frequency on. You then want to either type in the numbers or on your screen. So I'm going to type in 87, 93, etc. all the way to the end. And then I'm going to go back up to the top and I'm going to put in the ages. So I had 2, 3, 4, all the way to 11. Okay, then what I'm going to do, as usual, it's a bit funny, but I'm going to click all clear. I'm then going to hit Shift, 1, REG for regression, and then I've got some different values here and meanings here. One's the y-intercept, one's looking at the correlation coefficient. I'll put a video up on YouTube as well where Stuart Palmer describes this. I'll put it up for you on the Connect page, but we want number 3 here, the R correlation coefficient. So I'm going to hit 3, and I'm going to hit equals, and that is the value of my correlation coefficient. So it's 0.9950. Okay, so we're going to write that here. 0.9950 to 4 decimal places. Is this perfect, high, or low? Well, if it was perfect, it would have to be 1. It's very close to 1, so I would say it's high, positive correlation, because it's almost perfect. Okay, and then you could then, they could then perhaps in a HSC exam ask you to then describe what that means. So in this case, that means pretty much almost definitely as the student grows in age, their height also grows. Okay, so just as a reminder, we've talked about Pearson's correlation coefficient today. Just remember that this correlation coefficient describes the strength of a linear association or the relationship. It lies between -1 to 1. For a positive correlation, it will be between 0 to 1, and this means if one thing goes up, the other thing goes up. If one thing goes down, the other thing goes down. 0 means there's no relationship, that your scatter plot will be all over the place. negative correlation between -1 and 0. So if one thing goes up, the other goes down, kind of like inverse variation, if you like. And high correlation doesn't always mean that one thing causes the other. Okay, so write down any questions you have, perhaps a few more summary points. Have a go at exercise 6C, see how you go. If you want to pause any parts of the video or go back over it, feel free to do that. Thanks everyone, hope to see you soon.